Okay, in this question, we are asked which of the following will decrease the concentration of A if the reaction below is at equilibrium. Okay, so this is a question about Le Chatelier's principle. We know that according to Le Chatelier's principle, if you have a reaction in equilibrium and if you disturb the equilibrium through many different ways, you could add or remove one of the compounds involved in the equilibrium, you could change the temperature, you could change the pressure if there's gases involved, but if you disturb the equilibrium, the reaction will adjust, it will shift to re-establish the equilibrium. So that's what this question is really getting at. And it says, which of the following will decrease the concentration of A? So, let's think about that. So first of all, and I wrote this reaction down for each one of these choices so that we can kind of analyze each one independently. So, adding B. Let's think about if we add B, will that cause the concentration of A to decrease? We want to look for something that will decrease the concentration of B. All right, well, adding B would be like stressing that term right there. But the important thing to note is that B is a solid, and so it's not involved in the equilibrium at all. If I were to write the equilibrium constant expression for this, it would be, the concentration of C raised to the power of 3 divided by the concentration of A, and B does not show up because it's a pure solid. So adding B is not going to affect the equilibrium at all, so we can eliminate that as a possibility. Let's think about this one, adding C, all right? Well, adding C, that would be like stressing this side of the reaction. Okay, so that means, according to Le Chatelier's principle, if you stress the right side of the equation in a positive way, it's going to cause a shift in that direction. Okay, so that's going to cause my A to increase as well as my B to increase. Okay, so that's not going to decrease the concentration of A, it's actually going to increase the concentration of A. So I can eliminate that as a possibility. C, decrease the temperature. All right, so now for us to decide this, we have to look at this little part of the given information right there. It says that the delta H of the reaction is less than 0. So we need to remember from Chem 1 that means it's exothermic. Okay. Now when something is exothermic, that means that heat is a product. It generates heat, it releases heat. So I can think of, just like C is a product, I can think of heat as being a product in this chemical reaction. Okay, so when A and B react, they generate C, but they also generate some heat. And so if I decrease the temperature, that would be like a down stress on the heat. That would be like removing one of the products, just like if I had removed some of C. Well, if I remove one of these products, nature says, hey, well, I've got to shift to the right to compensate for that loss. And so that is going to decrease some of my A, and in order for A to go down, B has to go down as well because they react with each other. So it looks like C is the correct answer, but let's go ahead and think about D before we decide finally. So D says we increase the total pressure. All right, well, automatically let's just eliminate D because this only has to do with gases. Okay, changing the total pressure is only going to influence the equilibrium if there are gases, and none of these are gases. So it looks like C is your correct answer.